So the points which we have discussed so far, a quick recap of the points that we have seen so far. And I do have a couple of examples for you. A set will be a collection of objects. Objects are also called as elements or members of the set. If a particular element X is a member of set S, we are going to use belongs to symbol. X belongs to S. If X is not an element of set S, we will write X does not belong to S. This is known as does not belong. Examples, I could have set V of vowels in English alphabet. Remember that while listing out the elements of set, you are using comma to separate out, and all the elements of a set are present inside the curly braces. Start of curly brace indicates start of set and end accordingly. Let P be a set of positive integers less than 100. You are using this implicit notation. Okay. Implicit means we are using dot dot dot. We have seen yesterday. And the third type, set builder notation. This is listing method or explicit notation, implicit notation, and the third one is set builder notation. You are defining in terms of a predicate logic. We can also use a predicate notation for P. Let P be a set of all x such that x is a positive integer and it is less than 100. This we have discussed. Thereafter, we have discussed what do you mean by equal set. Two sets will be said to be equal if they contain exactly same elements. For example, 135 and 351 are equal. Again, those who are having confusion with this. Okay, the second example. As I said, set is a collection of unordered distinct elements. If you are observing that in this set we are having repetition 1 comma 1, 3 comma 3, comma 3 and 5. This is equivalent to 1 comma 3 comma 5. Why? Because this repetition will not be allowed in the definition of set. So it will have only three elements which are 1, 3 and 5 without repetition. So these both sets are also equal. How to define this? A set A is said to be next is subset. A set A will be said to be subset of B if every element of A is also contained in B. Yes. Okay. These two properties, every set is a subset of itself. The null set or empty set is a subset of all sets. Then I said, if we are having at least one element which is extra in the right hand side set, then we will say that it is proper set. A is said to be proper subset of B. We denote it using this notation without equal to sign. A proper subset of B if it is subset of B and A not equal to B. At least one element should be extra in B apart from elements in A. Moving further, this discussion is not cardinality, finding out the total number of elements in set theory. So let S be a set. If there are exactly n distinct elements in S, we say that S is a finite set. And the cardinality, we are going to use this symbol for representing cardinality. Two vertical lines with this set notation. Okay. Example is in front of you. Let A be the set of letters in the English alphabet. Then I would say cardinality of A would be 26. This is a finite set. A would be said to be infinite if it is not finite. Obviously, example set of positive integers, set of natural numbers, and so on and so forth. Then we have seen this power set. What do you mean by power set? It is denoted by P of S, set of all subsets of S. If S is having n elements, its power set will have 2 to the power n elements. Now this is the new point of today's discussion. Cartesian product. What do you mean by Cartesian product? Okay, if we have been given a two or more sets and we want to find their product will be known as Cartesian product. Observe, let A and B are the two sets. Whether it is fine. Now we are having 54 and I hope I am audible. Everything is going fine. Is it? I am audible. Is it? Yes. Oh. So Cartesian product. Let A and B are the two sets, the Cartesian product of A and B will be denoted as A cross B. Okay, do not say A multiplied by B. We are not multiplying sets. We are taking a cross product of two sets, and that cross product is known as Cartesian product. Okay. A cross B is the set of all ordered pairs A comma B, where the small a belongs to A and small b belongs to B. We are pairing the elements, every element of set A with every element of set B, like this. So what is the definition of Cartesian product? A cross B will be element A comma B such that A belongs to capital A and B belongs to B. We have to make all the possible pairs. That will be a Cartesian product. Example. Okay, let me say I am having a set A. Okay, having element. Let us say it is 1. A is having 1, and we are having set B, wherein I am having, if we are having set A with element 1, set B with element 2, my A cross B is going to be an ordered pair. If I am writing A cross B, element of A will come first and then I will have element of B. So that ordered pair 1 comma 2. This will be your A cross B. Remember that A cross B will not be equal to B cross C, because whenever in similar manner you have to pair 2 with A, 2 with B and 2 with C. This is the result of A cross. Let us check what is the result of B cross A. It will be inverse. I will be taking elements of B first. So A comma 1, A comma 2. Now A comma 1, A comma. Then the second element B comma 1, B comma 2. Then the third element C comma 1, C comma 2. You can write it likewise as well. So what is the property? The Cartesian product of the sets A1 comma A2 up to A of n, denoted by A1 cross A2 cross up to A of n, is the set of ordered n tuples. Tuples mean the elements inside these sets. Okay, A1 comma A2 up to A of n, where AI belongs to a particular set A of n. Okay. So this part is a generalization of two sets. Whenever we are taking a cross product of two sets, we are choosing every element from first set, pairing it with every other element from the other set. Likewise, this is applicable for n different sets as well. So, question for you: if we have been given A as 0, comma 1, B as 1, comma 2, and C as 0, comma 1, can you tell me what will be the value of A cross B cross C? Can you tell me the answer for this? A cross B cross C. I am waiting for your answers. Okay. Can you tell me? Yes. Can you tell me? Voice? No? No? What no? Am I audible? Is there any voice? Hello? Are you getting my voice? Now audible, okay. Whether you have not heard anything from the start? Have you heard anything from the start or you have not heard? Whether my voice was available from the starting? Middle side of couple, not middle side of couple. Middle slide of couple not audible. Okay, 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 okay. I will come back. No problem. Okay, just a second. Give me a moment. Okay? I will come back again to that particular slide, which is not audible. Okay. So up to this point, whether it is clear how you have computed A cross B and B cross A, this one was not audible. Okay. So if we generalize the concept of Cartesian product for n different sets, you could have pairing of all elements present in individual sets with elements present in other sets. So this is the generalized principle of Cartesian product. A1 cross A2 cross up to A of n will be ordered tuples A1 comma A2
Sir, your voice is getting diminished meanwhile.
my voice is getting
Sir, your voice is getting break down meanwhile.
okay. Okay, okay. I will check. Just a second. Hold on. Hello, hello. Now, whether it is fine now or still it is low or it is fine. Okay, hello, hello. Yes, yes, yes. So I think I have disconnected my presentation as well. I will reshare it. Okay, hold on, hold on. If it is clear, it's okay. Just hold on. Okay, that is good that you are responding. No? So that I come to know whether it is perfectly fine or no. Okay, so from which part I should repeat? Can you tell me which part should I repeat? If my voice is now audible, okay. Do you require anything to repeat from my end? Should I repeat this thing? The Cartesian product of sets varying from A1, A2 up to A of n, generalization. will be a1 cross a2 cross up to a of n. Given we will have ordered pairs a1, a2, an. These small a are representing elements of individual sets. And next I have given you a question. If we know set A having two values 0 comma 1, B 1 comma 2, C 0 comma 1, then what will be the cross product of A, B and C? That is the question to you. If it is fine, okay. Can you tell me the answer quickly? We have to cover a lot many concepts. Okay. So in cross product, I have to take pairs. So what will be first pair? We will be taking pair of two elements at a time for simplicity, and thereafter we can combine it with the third element. So Viraj has given the answer 0, 1, 0. Yes, yes. A cross B cross C. Prathamesh, correct. The answer expected was whatever Viraj has given 0, 1, 0, 0, 1, 1, 0, 2, 0, 0, 2, 1. Okay. So in general, if I ask you, if my question is, just hold on. If my question is, how many elements will be present in A cross B cross C? What will be your answer? The number of elements present in A cross B cross C will be equal to number of elements present in A multiplied by number of elements present in B multiplied by number of elements present in C. Right? So first we will be making a cross product of A cross B. It will hold four values. I will have 0 comma 1, then 0 comma 2. I will have 1 comma 1, 1 comma 2. Then I will apply this entire A cross B over C. So I will have first pair as 0 1 0, second pair as 0 1 1, and so on. Total I am going to have 8 elements in this A cross B cross C. So in general, the question is, if we are having cardinality of set A as M and cardinality of set B. Okay, what is the cardinality of set B? Let us say cardinality of set B is N. How many elements do I have in the cross product of A with B? How many I will have in A cross B? In A cross B? Vaibhav is saying 4. Where 4? In A cross B. Okay. Now I am asking for this in general, Vaibhav. If A is having M elements, B is having N elements, how many we will have in A cross B? That is my question. It will be, you said 2 into M plus N. Pranali, now it would be 2 raised to M plus N. It will be only M cross N. Okay. In power set, we are going to have 2 raised to M plus N. Pranali. Okay. I am not asking for power set. I am simply asking for this cross product. So in cross product, what we are doing, we are taking pair of every element from first set with every element for second set. You can observe here, there were 2 elements in A, 3 elements in B. So how many in a total? 2 threes are 6 elements in my cross product. So in general, M into N in the cross product of A cross B. Okay. So the answer for this is this one. You can cross check. 0 1 0, 0 1 1, 0 2 0, 0 2 1, 1 1 0, 1 1 1, 1 2 0, 1 2 1. In case you are getting a problem, you can approach me. Okay. Moving further. The questions for you. So if we are having set A having 4 elements 1 comma 2 comma 3 comma 4, and B is a set using predicate is set of all x such that x is a positive integer with its square value less than 20, then which of the following statement is true? This question was asked in the university examination as well. Okay. So out of these, which one is true? The comparison with respect to cardinalities. So C, all are saying C. Okay, A equal to B. Okay, let me check. So what are the values of b? Can we have 1? Yes. What is the square of 1? 1, which is less than 20. Okay. Can I have 2? Square of 2 is 4. 4 is less than 20. Yes. Can I have 3? Yes. Because square of 3, 9 is less than 20. Can I have 4? Yes. Because square of 4, 16 is less than 20. Can I have here 5? Can I have here 5? I cannot have here 5 because 5 square is 25, which is greater than 20. It does not satisfy this condition. Again, somebody may have a doubt in mind. Why only 1, 2, 3, 4? Why not 0? Why not minus 1? It is specially mentioned that x has to be a positive integer. So positive integers are the integers greater than 0 up to infinity. Again, there is one more restriction. The value of square should be less than 20. So both the sets are exactly equal. 1, comma 2, comma 3, comma 4. So the answer is in front of you. So we would have option C as the correct. A equal to B. Okay. What is the answer for second? For any two sets A and B, if A is subset of B and B is a subset of C, then which of the following statement is true? B. Absolutely fine. Okay. Yes, correct. How come? With the help of example, it is explained. Okay. Observe. Let A equal to 1 comma 2, B equal to 1 comma 2 comma 3, and C equal to 1 comma 2 comma 3. What is given? A is subset of B. Do we have A as subset of B? Yes, A is subset of B. Do we have B as subset of C? Yes. So can we infer A is subset of C? Yes. By the definition of subset, if A is subset of B, that means every element of A is present in B. If B is subset of C, that means every element of B is present in C. Hence, we have to cross verify and find out that the answer A is subset of C would be true to the best of our knowledge. Is it fine now? My voice is fine. Is there any still disturbance? Voice is fine. Okay. Okay. Good. Okay. So going back to the slide, definitely changing my presentations, okay, so that you will have all possibilities explored without anything missing. That is the reason, nothing else. We have seen this yesterday. Okay, so not only for numbers, this Cartesian product can also be applicable for letters as well. So you can observe here A is having elements Charlie, UC, and Linus, and B is having elements Brown and Manfred. So you have to pair the element of A with B. We are having in total 6 elements in a pair. That is the Cartesian product. Uh, so if this is clear, let us go on with the operations of set theory. Okay. So there are four major operations on the set theory, namely union of two sets, intersection, difference, and symmetric difference of two or more sets. So if I'm interested in knowing what is union of two sets, the union of A and B will be written as A union B is the set whose elements are the elements of either A or B or both. So we are going to take the elements which are present in first set or the second set or the elements which are available in both the sets. So notation is A union B, this simple union. Any disturbance from my side? Somebody is speaking in the mic? Who has joined? Any problem? Okay. So example is in front of you. Let K be a set having two elements A comma B, L be a set with C comma D, and M be a set with B comma D. Then union will take all the elements. So we are having A comma B comma C comma D, A B C D. While taking union of K with M, I am observing that B is repeated. So I will not take B in the repeated fashion. I will consider B only once. So the union of K union M is A comma B comma D. You should not write A comma B comma B comma D, because instead you are not going to have any repetition. It will have all distinct elements. Okay. So what is union of L with M? It will be B, C, and D. D is repeated. Still, we are taking it only once. Okay. So, how can I define in terms of predicate or set built-up notation? A union B is a set of all X such that X belongs to A or X belongs to B. Intersection is advanced part of union. In intersection, we are taking only those elements which are common in both of the sets. So intersection of A and B, written as A cap B, A intersection B, is the set whose elements are present in both A as well as B. It should be present in A as well as B. Okay. So in the predicate notation, we have to use here and. X must be available in A as well as X must be present in B. That is intersection part. Simple. We have studied in the 12th. Okay. Examples. Let K equal to A comma B, L equal to C comma D, and M equal to B comma D. Same. Then if we are finding intersection between K and L, I am observing that there is no common element between set K and L. So the result is 5. While in K and M, we are observing that element B is common, so that will be present in intersection. So in the case for L, intersection M. Next is difference. So difference of sets A and B is written as A minus B is the set wherein elements are the elements of A which are not in B. That means we have to take only those elements which are exclusively present in left hand side set, but at the same time those elements should not be present in the right hand side set. Try to get this thing. Okay, difference. A minus B is all X such that X belongs to A and X does not belong to B. So let K, again the four sets. Okay, if I am interested in K minus L, all the elements of A, but at the same time these elements should not be available in B. So what are the elements of A comma B. What are the elements of B? C comma D. So I will say A comma B. All, just observe, whose elements are the elements of A, left hand side set, but not in right hand side set. If we are computing K minus M, I observe that A is exclusively present in K, but it is not present in M. Okay, so I am saying A. Can I take B? No, because B is available in M as well. There should be exclusive presence of an element. So K minus M comes out to be A. If you compute L minus M, it would be L minus M. Okay, so we will skip D. We are going to have only C as the element. Okay. Moving further, symmetric difference. Okay, denoted using symbol is XOR operator. The symmetric difference of sets A and B, denoted by this notation, consists of only those elements which belong to either A or B but not both. We have to find out only those fixed elements which are present in either left side or right hand side but not both. How can I represent that? A symmetric difference on B is nothing other than A minus B union B minus A. A minus B union B minus C. This can also be written as A union B difference with A intersection. Don't get confused. We are going to have several examples on this. I am just trying to introduce you about the operations on the set theory. So we have seen union, intersection, thereafter difference, and the symmetry difference. So let's have a look for the examples of this one by one. Okay. So in union, as I said, I will be taking all the elements together. Okay. How it is represented in the Venn diagram, a diagrammatic representation where circle represent a set, rectangle represent a universal set U. Okay. If I am interested in having A union B, I will have all the elements present in B as well as elements present in A. This entire part. Okay. Intersection, observe. Okay. We are having this Lucy has a common between A and B. So that will be present in intersection. Venn diagram. Only this shaded part, this part is representing your A intersection B. The elements which are shared in both of the sets. A intersection B. While here we were taking all. Okay, this entire thing, this entire shaded region is talking about A union B. That is not the thing with intersection. We are having this shaded part. Okay. This was one more operation which was missing. Okay, in earlier slides, the complement of a set A is denoted by A bar. What will be complement? Complement will be set of all elements which are not present in A. So that will be complement. Just observe. If A is set of all X such that X is bored, X is a student who is bored with this lecture, then what will be its complement? A bar. It will be set of all elements who are not bored with this lecture. I hope this is clear. We are going to take opposite. Whatever is present, apart from that, whatever comes, we are going to take it in the complement of set. What will be the Venn diagram representation of complement? If I am having set A, then the complement will be denoted by this shaded part. Complement is set of all elements other than E. That is represented as A bar. Oh. Further to this. Okay. These are the properties that I will discuss shortly. What is the complement of null set? If we take complement of null set, it will be universal set U. And what is the complement of universal set U? It will be I, a null set. Okay. So, difference between A and B. Difference between A and B, I have to look for only specific elements present in this A. At the same time, those elements must not be present in B. We have to exclude the elements present in this shared part while taking a difference of A and B. So this shaded part will denote A minus B. So it is denoted using this X belongs to A and X does not belong to B. This law we will talk about shortly. A minus B is nothing other than A intersection B complement. Once I come to this point, I will discuss more. Okay. Symmetric difference is combination of A minus B union B minus E. Elements which are exclusively in A but not B, or exclusively in B but not E. How its diagram will look like? It is like exclusive OR. Okay, so only the elements from B, only the elements from A, except this, we have to exclude this part. Okay. This part you are going to not take, cross. Okay. Further to this. Okay. If this is clear, whether this is clear? Can you reply in the chat box whether this is clear? Yes. So let me open my notepad so that I can understand if you have understood anything or not. Let A equal to 1, comma 2, comma 3. Let B equal to 4, comma 5, comma 6, comma 7. Let C equal to 2, 3, 5, 7, 9. Let U equal to 1, 2, up to 10. Very quick. Okay, we have to cover lot many examples. Okay, so be quick. What will be A union B? Second, what will be A? See, I am not having intersection symbol at my end, so I am typing this. This is not intersection. You have to write in your notebook the intersection symbol properly. Next, let us say you have been asked to find A minus B, fourth one, A. I am writing plus, but plus with the XOR operator will be for symmetry difference. Do remember. Okay. And let us say I am asking you to compute A with B with C. I want. I am writing this negation like notation, but you should use bar. A bar. Then let us say I want A bar union negation of B. Next, let us say I want negation of C intersection D. Are you ready for the answers? For that, you should ask me what is the question. So, question is in front of you. I am not having that symbolic editor with me. That is the reason why I have written intersection like this. You should write intersection properly. And this is for symmetric difference. Okay. You should write it as well properly. Example number 9. Example number 10. Remember, we have been given universal set U as well. What is the answer for first? Brudil is saying 1 to 7. Correct. Very nice. Okay. So I will not have more time on this. 1 to 7. We have to take all the elements as it is. Okay. Intersection. Second one. Intersection is 5. Okay. I am not observing any element common. So it is 5. Okay. See, I am discussing this little bit fast. If anything is not clear, feel free to ask me in the chat window or by turning on your mic. We are not observing any element common between A and B. Hence, the result of A intersection B is 5. So what is A minus B? That is my third question. A minus B. All the elements which are exclusively present in A, but at the same time, they should not be present in B. 1, 2, 3, you are saying. Okay. So if I add one more question here, let us say 3.1. What will be result of A minus C? Can you tell me what is the result of A minus C? 3.1. A minus C. Yes, very nice. A minus C will be 1 because 2 and 3 are common with C. Perfect. Okay. Fourth one, A plus B. What is A plus B? Either in A or B, but not in both. A plus B. Only A 1, 2, 3. Only B 4, 5, 6, 7. Okay. I will have all the. Very nice. Okay, fine. A intersection B intersection C. 1, 2, B. No, nothing. Okay. If you find and then empty set. Very nice. Very nice. Good to see. Negation of A. Negation of A will be set of all elements which are not present in A, but those should be available with U. We will be taking a reference of U, universal set, while computing complement. Yes, 4 to 10. Very good. 4, 5, up to 10. So yes, too fast. Okay, good to see that all of you are taking interest and solving. Okay, I am waiting for the answer for 7 now. Negation A, union negation B. Who said 1 to 10? We have to compute negation A, union negation B. 1 to 10. Whether the answer is 1 to 10, negation A, union. Yes. We think, okay, step by step, step by step. Sejal, Vaishnavi, you are saying 8, 9, 10. How come? I think the answer should be 1, 2, 3 up to 10, isn't it? So let us go step by step. Okay. How it comes 1 to 10, let me explain. So what is the negation of A? Negation of A is elements from 4, 5 up to 10. Is it fine? We will not take 1, 2, 3 for negation of A. Whole union with negation of B. So those elements which are not present in B, but those are available in U. So which are those elements? I will have 1, comma 2, comma 3. Then I will have 8, 9, and 10. Am I clear? These are the negation values of A as well as B. If we are taking union of this, what will be the result? Abhishek, what will be the result? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You are going to have everything, and that everything is present in universal set. Very fine. Abhishek Thamkar, how you are saying 1 to 9? Yes, 1 to 10. There was somebody who was saying 1 to something 8, 9, 10. Prithviraj, Aditya, whether it is clear? How it is coming 1, 2, 3, 4. Okay, okay, fine, fine, fine. Shall we proceed? Okay. So example number 8. Negation of C intersection A. What is negation of C intersection? So I think you're giving answers. I'm not able to see. Okay. So what is the answer? 1. All are saying 1. Abha is also saying 1. Okay. So let me check. Negation of C. I'm going to have 1, 4, 6, 8, 10 in negation of C. Intersection with 1, 2, 3. Okay, 2, 3 are gone. So I'm going to have obviously 1. Perfect. Further to this example number 9. What is symmetric difference of B on A? B on A. Yes, symmetric difference of B on A. Whether it is 1, B on A. Exclusively available in B, but at the same time they should not available in A. Again, exclusively present in A, but not with B. I am asking for example number 9. Now, I think you have written down these sets. Okay, you are having these sets with you. B symmetric difference on A. 1 to 7. Very good. 1 to 7. Perfect. Okay. A plus B plus C. A plus B plus C. Are you talking about example number 10 now? Symmetric difference of three sets A, B, C. How to compute? First of all, compute A plus B. You are going to have 1, 2, 3, up to 7. Okay. Then compute with respect to C. And tell me the answer. Now the answer will vary. Okay? 1, 2, 3, 4, 5, 6, 7, 9. Abhishek is saying. Okay. So let me cross check. I will say this set is 1, 2, 3, up to 7. This is equal to. Yeah. Taking part by part. A symmetry difference B, I know that it is 1 comma 2 comma 3 up to 7 plus what is C? Let me write C one more time. Is this one I have written. Okay. Now I have to compute symmetry difference. So elements which are exclusively present here, but they should not be shared there. So 1, whether 1 is exclusively available? Yes. 2, 3 I cannot take. Next 4, yes, I can take 4 because 4 is not available. 5 I cannot. Can I take 6? Yes. Can I take 7? No. So these are the elements from this particular thing. Okay. Yes, right. Now let us check for this. 2, 3, those are present. 5, it is present. 6, 6 is okay. 7, 7 is present. 9 is not present. So I am having answer as 1, 4, 6, 9. Okay. How many of you are now clear with this answer? How it comes 1, 4, 6, 9? Whether it is clear how it comes? You have to take part by part. Okay, you can either consider B plus C first and then A, or A plus B and then C according. Oh, now it comes 1, 4, 6, 9. Oh, one more question for you. Okay, not related with this, something different. If this is clear. Let number two, let A equal to A comma B comma A comma B comma A comma B. Okay, state true or false. This is given to you. Okay, state true or false. Example number A. A. See, again I am not having that belongs to symbol, so I am using this E. E for belongs to. Actually, it is belongs to. A belongs to the first statement. B. People are giving answers. Okay, so let's go one by one. What is the answer for first? Let me check out. I think somebody has given the answer. Okay. True, false. Somebody is saying true, false. Okay. One by one, I will discuss. So all are saying perfect. Okay. A belongs to A. Whether we have A as an element of A, whosoever has said false. Okay. Do we have A belongs to A? Do we have? What is first? First is true, isn't it? Because I'm observing that A is a member of set A. Do I have A with curly braces as a member of set A? I'm now talking of example number 2. No, it is false. Perfect. Okay. Why this is false? Many students are having confusion in this. Why this is false? While writing element, you should not write it in curly braces. So you are simply checking whether this element belongs to set. Yes, it is. Why this thing is not present here anywhere. So it is false. Okay, third one. C. Element A comma B belongs to A. Yes, now I think you are observing a difference. What is the difference? I am observing A comma B within the curly braces. Now both are belonging to this. So this one is true. Oh, fourth one. A comma B is a subset of A. Is it true? Yes, it is true. Okay, how come? I am forming a set with one element as A comma B. Can I form that set? Yes, because we are observing that this is present A comma B. I would say that this is true. That's fine. Okay, how about fifth one? Final one, fifth. False. Why false? Because there is no any element with the curly braces that is B and which is present in set. This one is. I think okay. We are now quite familiar with these notations, is it? Okay. Next is F and G. Okay, how about F? F is false or true? I do not observe any empty element present in set A. So this one is false. Okay. How about this? Null set. Whether null set is a subset of A? How about G? G is true. Why true? Because every set has a subset as null set or empty set. Okay. Okay. Any disturbances? Somebody's mic is on. Can you turn it off? Okay. I am exceeding your lunch time. Okay. Should you do you want a new example to solve? Shall we stop for today? Any one more example? Do you want to try? This is clear. Okay. Shall we try for new example? Sure. Aditya is saying sure. How about others? I'm observing 59 are there. Okay, good. How about others? Shall we try one more? Yes. Okay. If it is comfortable from your side, I am there. Okay. To conduct 2 hours lecture. No problem. Next one is identify whether following states are finite or infinite. You have to tell me along with cardinality values if any. Okay. Number of songs sung by Arjit Singh. Second, number of lines in origin. Number of books in the world. Based on written output by passing by. You have to tell me whether these sets are finite or infinite. All are finite. First one is finite. Okay. Second one, we are saying first one is finite. Okay. Second one is infinite. Perfectly fine. Why infinite? Because we cannot count the number of lines passing through origin. You would have any. Number of books in the world, finite, isn't it? Number of books in the world, it will be finite. Okay. And ways of getting output while tossing a coin, obviously those are finite because I know that I'm going to either get a head or tail. Okay. Such questions would be asked in your examinations and you should feel it comfortable to solve accordingly. Okay. One last question before we conclude for today. The very last question. I will not take much. So let us say I'm having set x 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7 comma 8. This is my set x and you have to tell me true or false. State true or false. Okay. Example number 8. Fine. Example number B. That 8 belongs to x. Last. Yes. Okay. So answer for first. One belongs to x. One belongs to x is I think false because we are not having any such element present. Okay. First is false. Second one 6, 7, 8 belongs to x. Second one is true. Okay. Third one 4, 5 belongs to x. 4 comma 5 belongs to x. True. 4 comma 5 belongs to x. Okay. 4 comma 5 is a subset of x. How about fourth one? We say false, false, false. Which one false? 4 comma 5 is subset of x? True. Because I am observing this. Okay. 4 comma 5. It is specially mentioned in the base. 5 belongs to x. 5 belongs to x. 5 belongs to x. Do we have 5 belonging to x? False. False. Okay, false. So I will post a recorded version of this on your classroom. You can try, explore, and in case you are not satisfied with the answer of any, you can discuss with me. Okay. Many examples in coming classes. Till the time you can start your camps. Okay. We can have your quick attendance and thereafter we can stop for today. We can certainly start. Sir C is F. We send Abhishek. Sir C is F. 4 comma 5 belongs to X. 4 comma 5 belongs to X is F. Abhishek is saying. Okay. So what is the answer for C? C is F. C is F. C is F. Just hold on. Let me restart my presentation for a while so that there will not be any confusion before leaving this class particularly. Okay. Yes, you are saying C as well. Check out inside the bracket we have been given 4 comma 5. So do we have any element like this with the two braces 4 comma 5 here? We are not observing anywhere with the two braces 4 comma 5 present. So this would be false. 3.1, let me have. If you want to make it true, you should not have this extra bracket. Okay? If extra bracket is not present, you would say it as. What do you want to say? Is it? Is it? Is it the case that you are saying like this? Okay. So I will again restart. D is false. Who is saying D is false? D is not false, Aditya. Why? Because you are forming a set, and inside that set, this set is formed. Okay, this entire thing. Inside that set, we are having one element with 4 comma 5. Okay. Do we have such element 4 comma 5 together in a set X? Yes, that is existing. So this set could be assumed as a subset of X. Hence it is true. Is it Indiraj? Why is true? Because in our set X we are having entire element with a collection 4 comma 5. I have formed a set wherein a single element 4 comma 5 exists. So using this single element, whether this single element set is acting as a subset of X, yes it is. That is the reason why I am saying it as a true. Everything is it fine? I hope it is clear. Still anything, if it is not clear, you can discuss. Okay. 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 Turn on your cams. Let me have your quick attendance. Okay. Where can I see? Okay. All 1, 2, 3, 4, 5, 6, 7, 8, and so on. Okay. Good. Good to see you all. Okay. See you tomorrow morning at 9 a.m. 9:15. Sorry, 9:15 a.m. Till the time, have a great day. Okay. You can leave this meeting.